Hello, welcome you all in PG lectures. In carbonyl compound, today I will discuss the formation of imines by the carbonyl compound. In my previous lecture, I told you the formation of hydrates, formation of acetal, hemiacetal, formation of cyclic hemiacetal and cyclic acetal. Now let us see the formation of imines by the carbonyl compounds. Now, formation of imine or this imine previously, and this imine is actually, if you see, we have a carbonyl compound and this carbonyl compound that can be converted into this imine. So this is imine. When the C double bond N is present, then that is called as the imine. Now if we have a hydrogen over here, and or that means from aldehyde this imine would be formed, and if we have a ketone, that's imine, this would be the imine. Okay. Now in place of R, if it is converted into, suppose this is the alkyl group, and in place of this alkyl group, if we have a hydroxyl group, then that is called as the oxime. So these both are imine, and this is called as the aldimine because it is formed from the aldehyde, whereas this is called as the ketamine because it is formed from the ketone. Now in place of R, if we have a OH group, then that is called as the oxime. And in place of this OH, if we have NH2, then that is called as the hydrazone. So all these are similar type of compounds. These are the when this carbonyl group can be converted into this similar type of compound. So that is called as the. Now in previous days, this imine, that is this functional group C double bond N, that is also called as the azomethane functional group. Azomethane. Nowadays usually we use a word imine in place of this azomethane. Now how we can form it by the carbonyl compound. So if I have a carbonyl compound, then this carbonyl compound in presence of H plus, and suppose if we have any primary amine, so this is a primary amine. So for the formation of this imine, oxime, or so we should have a primary amine. So that can be converted into imine. So this is our. Now suppose if this R is equal to any, suppose it is methyl group or any alkyl group. If we say R is alkyl group, then that is called as the imine is formed. And suppose if R, it may be, suppose I write it NH2. If R is NH2, then it is called as that is called the hydrazine. So it means if R is NH2, and then it is hydrazine, and then in that case what is formed here? Hydrazone is formed. So imine is formed here. And if R is NH2, it means a hydrazine. If you are taking hydrazine, then hydrazone is formed. And if we are taking R as a OH, that is the hydroxyl amine. Okay, that is NH2OH, that is called as the hydroxyl amine. Then in that case, what is formed? We get a oxime. So this oxime, we know that this is used in a Bachmann rearrangement reaction, whereas this hydrazone, this is used in a Wolff-Kirschner reaction. And suppose if we have a this one, we have NH, and either we may write PH, or if benzene ring is attached over here, means, so in place of R, if we have NH this, then that is called as the phenyl hydrazine. In place of hydrazine means if one H is replaced by this phenyl group, then it is called as the phenyl hydrazine. And so the product that we obtain, so this product we obtained is the phenyl hydrazone, is the product, phenyl hydrazone. And now if we have a, suppose so if we have a 2,4-dinitrophenylhydrazine, if we have a 2,4-dinitrophenylhydrazine is formed over, okay. So the product formed is the 2,4-dinitrophenylhydrazone that would be formed. So it would be 2,4-dinitrophenylhydrazone. Phenylhydrazone that would be formed. So this is 2,4-dinitrophenylhydrazine. So if amine is 2,4-dinitrophenylhydrazine, then product, that is type of imine which is formed, is the 2,4-dinitrophenylhydrazone that would be formed. So this is a general reaction for different, if we use different type of imine, that can be, and this is a general type of reaction. Now let us come to the mechanism for this reaction. So no doubt this reaction is also this reversible reaction, similar to the previous reaction that we have discussed, that is the hydrate formation or acetyl hemiacetal formation, that were also the this reversible reaction. Now, so if we see the mechanism for this reaction, now this mechanism. So first of all, this carbonyl compound, if it is present, then it is protonated to make this carbonyl center strong electron deficient. So we will have a oxygen which is protonated over here, and positive charge will come at this oxygen. And now next we have suppose we have amine. If we have this amine, ethylamine, suppose this is the ethylamine that I have taken. Now this ethylamine, now it can attack over this strong electrophilic center. Positive charge is pi bond breaks, positive charge will get neutralized. We have OH over here, and we have NH2. So one of the hydrogen over here, another hydrogen over here, and this type. And positive charge will come over this. Now in next step, this one of this hydrogen that can be replaced. This hydrogen has become the acidic one, and that can be replaced, and that can be replaced by base, and base here is the primary amine, is the base over here, and that can replace this one. So now if we have again primary amine, now primary amine here, that will, here the primary amine acts as a nucleophile. Now here the primary amine, it can act as a base, and it can take out this acidic hydrogen, and what you will get, OH and okay. So also suppose if I take a few drops of HCl, acid added is a few drop of HCl may be added, or some other acid. So if HCl is there, then no doubt in counter ion that would be present in a reaction mixture. So counter ion, that would counter ion Cl minus, that would be present in a reaction mixture. You can write it, and in some books it is written, in some books it is not written, or otherwise here also we can write the counter ion which is present over here. This is the counter ion. Okay. Now in next one, this acid is present in the reaction mixture. So this acid, it will protonate this one, and we have a now elimination of this wood H2 will takes place, and positive charge will generate over here, and we have NH. My next step, this positive charge that would be utilized, and we have this imine formation. So now again we have a base. This will act as a base now, a primary amine, and it can take this proton. It can take this proton. Positive charge is neutralized, and you will have a imine now. So imine is formed in this way, and as you can see, plus what you have got, we have got NH2, or I can write NH3 plus this one, or we can say the acid is again, that acid here is in a catalyzed one. So this is acid catalyzed reaction. At the last, the acid is regenerated. So this is the mechanism, and in first step what you have seen, protonation. This is the protonation step. Second step is the nucleophilic addition. Third step is the deprotonation again. Fourth step is again protonation. Fifth step is the elimination step. And now next step what you have seen, it is protonated over here. So sorry, again, and this is deprotonated over here, and finally we have got after deprotonation we have got the imine. So this is the formation of imine, or mechanism for the formation of imine. Now, one of the another reaction, that is the intramolecular imine formation. Suppose when this NH2 group, here this carbonyl group and this amine, they are separate one. Now, if these two groups are present in a same molecule, and that is called as the intramolecular imine formation. So let us take the example of intramolecular imine formation. That is when carbonyl group and the imine, primary imine, are present in the same group. That is when carbonyl group and primary amine group are present in the same molecule. Then in presence of mild acid, we can get the product via intramolecular imine formation will take place. Now suppose if we have this carbonyl aldehyde and this is amine. As you can see, aldehyde and amine are present in the same molecule. Suppose this is 1, 2, 3, this is 4, this is 5. Now in presence of mild acid, so first of all, what will happen? This will get protonated. This is protonated, and finally what you will get after protonation? Okay. Now a strong electrophilic center is generated over here. Now here this as a nucleophile, this will attack over this electrophilic center and this. So what you have seen, so you may write this one. positive charge over here comes. This is converted into OH group, this is H, and bond is formed between this carbon and this one, and then that can be written in this way. I can write, so 6 membered ring, that is, if this is first, second, third, fourth, fifth, and this sixth, so 6 atoms, so 6 membered ring that would be formed. So if we have this NH2, and one of the hydrogen over here. So now in next step, intramolecular internal proton transfer takes place, or via same reaction that I told you. First of all, what can happen? The base can take out this H plus, and again after that this OH that would be protonated, H2 would be removed, and finally what you will get. So suppose I can show it in a internal proton transfer. Suppose internal proton transfer takes place. Suppose I write it in a different way, internal proton transfer. So otherwise a base, the same amine can act as a base. It will take out this H plus, and then this acid will, this OH that would be protonated by the acid, and then that would be converted to H2O. Or otherwise the internal proton transfer can be shown in this way. So now in next step we have one of the positive charge over here. In next step, this positive charge that would be removed by base, again base, same base, or some this internal, this NH2 can take out this NH2 as a base can take out this proton, and we have a imine formation. Okay, so this is called as the intramolecular imine formation. Now one of the questions that arise here, that always during the formation of a imine from carbonyl compound, I have taken a primary amine. Why don't may take a secondary amine? So let us see what happens when a secondary amine is taken in this reaction. So what question arises? Why secondary amine can't be taken for the formation of imine? Now suppose if we have a carbonyl compound, and so first of all I protonate it so that this carbon becomes a strong electrophilic center, positive charge, and now we have a secondary amine. Now in place of a primary amine, let us take a secondary amine. So this is our secondary amine. Okay, now so this will act as a nucleophile. It will attack over this electrophilic center, and what you will get? Positive charge, pi bond breaks, positive charge get neutralized, OH comes over here, and we have okay. Now in next step this would be removed by base. Suppose if we have a base, and base, either this can act as a base, as I told in my previous mechanism, this may also act as a base. So this acts as a base, it will remove this H plus, and this positive charge is neutralized, and we have this OH, and okay. Now in next step, what you can see, in next step it would get protonated, this OH is protonated, and finally positive charge over here. Sorry. So after removal of H2O, we are having this positive charge, and nitrogen, it is having one of the lone pair, and positive charge is neutralized, and we have this one. So what we have seen, now suppose here I am taking this acid is coming from, suppose I take it as HCl is present, so it means in reaction mixture we have a Cl minus ion. So this counter ion, I may write a counter ion over here, Cl minus. In the same way, I may write a counter ion as a Cl minus, either Cl minus can take this H, okay, or either this may take this H. Okay, Cl minus act as a conjugate base can take this H, or otherwise this amine as a base can take this H. Both is possible. Okay, now this Cl minus is also present here in reaction mixture. We have a Cl minus here also, we have a Cl minus here also. So what we have got here, we have got this imine salt. We have got, in place of imine, we are getting the imine salt. Okay, so in place of imine, we will not get the imine, we will get the salt of imine. Now in next step, what we can do, suppose if we have a base, then this base can also take this hydrogen. Suppose we have one of the acidic hydrogen is present over here. So this acidic hydrogen, so base may take this acidic hydrogen, and so this bond will come over here, positive charge is neutralized, and what you will get, so this HCl will come out, and this positive charge is neutralized. So here that would be converted into N, and one of the double bond will come over here. So this is called as the enamine. So enamine we get formed. So either you will get, when we are using the secondary amine, then we may get with either imine salt would be formed, or you may get the enamine. So this is about the formation of imine, intramolecular imine formation, and I explained why don't we use a secondary amine for the formation of imine. Thank you.